Good morning. I hope everyone's excited and strapped in. I have the great pleasure of inviting everyone in for science-related projects, experiments that will be hosted by our corporate partners, which include DuPont, Boeing, FMC, ILC Dover, and Elite Universal Network.
Hi, I'm Maggie Eicks, and I am here to talk to you guys about STEM and how to solve complex problems. But before we get started, I would like to show you a STEM motivational video and how STEM is used in our everyday life. How cool was that video? I am super excited to get started. But before we do, I am going to talk a little bit about myself and my work experience. So I was born in College Station, Texas. So born and raised in Texas, and I currently live in Philadelphia. I have one sister. She lives in Austin, Texas. And I currently have a Bachelor's of Science degree in Industrial Engineering. And I am currently getting my Master's in Systems Engineering. For hobbies and interests, I like to run and bike and swim and travel to different places. I went to Yellowstone National Park with my girlfriends, and we saw bison and bald eagles and rode around in snowmobiles. It was really, really fun. For work, I currently work for Boeing. And before Boeing, I worked at Schneider Electric as a manufacturing engineer. Within Boeing, I've had multiple positions. I was Boeing research and technology, and then in industrial engineering, and then a production engineer, and then I went into operations management. So with Boeing, what do we build? We build all sorts of stuff, all sorts of items in aircraft. We build commercial aircraft, defense aircraft, and then we are in space. So we build satellites and rockets, and that is just to name a few. But one thing is in common with everything that we build at Boeing: they fly. So what are the forces to make it fly? The top forces, 4 forces, is lift. So that's to help make it go up. And we have the thrust to help it make it go forward. And then we have the weight. So how much weight can we hold and still go up? And then we have the drag. The drag doesn't help slow it down. It helps actually direction. So if we want to go left or if we want to go right. But those are the 4 forces to help make it fly. We got the lift, the thrust, the weight, and the drag. So how do we make that happen? How do we make that happen at Boeing? We have all sorts of different types of engineers and scientists. The types of engineering at Boeing, to name a few, is aerospace, chemical, civil, industrial, like me. And then types of scientists at Boeing can range from physics to chemists to material science. We have a wide range of people to help build the aircraft that we build at Boeing. And we all put our heads together to help solve complex problems. From my own experience, the best thing I've ever done was build an assembly line. And that really opened up my eyes to technology in the technology field. It really gave me insight of what I wanted to do. So I tied in both my education with industrial engineering and tied it in with technology. So I look at processes and seeing how do we make this process faster. So a process engineer. So for example, if we want to make a peanut butter jelly sandwich, how do we get the peanut butter and jelly on the bread faster so we can eat the sandwich quicker? So I look at those processes and I ask, okay, what kind of technology can we implement here? What kind of tool can we implement? What can we make modifications with to make the process go faster? So that's sort of like my typical day. What I was like in high school is totally different. I was very focused on athletics. And through athletics, I really developed the skills to be a team player and to work together as a team. I learned how to communicate as a team, how to work with others, how to achieve the same goal together. I use those skills every day today throughout my work and in my personal life. Being able to work together as a team and being able to communicate is a huge skill set to have and to practice. What other kind of skill sets do we use to solve complex problems? We have problem-solving skills and we have conceptual understanding of science and engineering. That one's big. That one's a big part of being successful in solving complex problems. For example, we know that 1 + 1 = 2. We could use that knowledge and expand it to solve even harder problems. But without that base understanding, it's hard to expand. So it's really important to understand the conceptual understanding of the basis to be able to solve those hard problems. What kind of skills do we use? We use curiosity, creativity, and persistence. Persistence is the key to it all, and to never, ever give up. Rarely do I ever get it right the first time, but it's with that persistence and continue to try until we achieve what we wanted to achieve is a huge piece of being successful. So with persistence, it's all about never giving up and continue to go forward. And you're not going to get it right the first time. It rarely ever happens. So continue to do that to be successful. How do they help us grow? Creates a unique solution, innovation. And then we are encouraged to redesign. So can we, for example, can we make the part smaller? Can we make the part stronger? Can we put it in a different orientation and still have the same functionality and capability? All of these questions really help us solve complex problems and really help challenge us continue to grow and improve. So what kind of steps do we take to be able to create and achieve our goal? We drive inspiration. We could get inspiration from anything, from being out walking outside, to talking to someone, to looking at art, to even daydreaming. We can drive inspiration from all sorts of different sources. So once we get the inspiration, then we want to go into the plan phase. So the plan is, all right, what kind of steps do we need to take? What kind of material do we need? Our tools? What are we really trying to achieve and create? So writing down that plan is a huge part of it to be able to go to the next step. And that's when we want to build. So we want to take our plan and then we want to put it into the action. So we want to start building what we want to create. And then we want to test it to see, all right, did we get what we really wanted? Do we need to tweak something? Do we need to modify something? What did we learn? So we want to take that test knowledge and redesign. And we want to keep going through that process until we get something that we are happy with and that we're good with. So once we're good with it and we're happy with it, we achieved what we set out to do. Then we want to reflect. We want to see, okay, what worked? What didn't work? What do we want to do next time? What was our lesson learned? So that's our reflection point. It's super important to reflect because then we can grow and always learn what to do for the next time. So who goes through the engineering design process? Everyone does. It's not just engineers. It's not just scientists. Everybody can create and everybody can go through those steps to solve complex problems. So I think it's time for us to create and build. Our design challenge is to design and build a no-wire circuit. So we want to create a circuit that has no metal wires and uses at least 3 different conductors. So I am going to stop sharing and flip it over to our material table. All right, as you can see, we have all of our material. So we set out for a plan. We want to build a no-wire circuit. So we have our 3 different conductors. We have a wire, we have aluminum foil, we have paper clips, we have a battery, and we have our light. So in order to make a circuit, we want to kind of draw out our plan. Where do we want to place some things before we tape it down and make it permanent? I'm just going to move some stuff around and see what would work and what maybe won't work and what would fit. All right, so I want to connect these 2, right? The battery to the light. All right. And we got our tin foil. I'm going to see if this will work. That's too big. So I'm going to go ahead and cut it. There we go. All right. So we got one of the conductors connected, and then we want to keep it to the battery. All right. So I think I got what I want to do. And I'm going to let you guys try. But I'm going to slide this over and show you one that I've already created so you guys can get a little insight of what we want to try. So here we got our 3 different conductors. We got our full circuit and we got our battery. So I'm going to try it out. Up, so the light didn't work. Now I'm going to go back to the redesign. I'm going to see if I just flip the battery, see what happens. Awesome. It worked. Perfect. So now it's your turn. Now, challenges to you. Build a circuit with no wires. And as you're going through this activity, always remember to never give up.